All right, second half of question 4. Got this far, and now we're talking about vocab. So the vocab is union and intersection. So I want to talk to you very briefly about Venn diagrams. This is Venn diagram vocab. So Venn diagrams always must have a rectangle on the outside that is the entire sample space. And then inside you have some combo of things that interact in some way. So the idea is you have it's called compound events, so two different events, A and B, and how they might interact with each other. So the first question is asking about union. So union, vocab-wise, union means you want both circles as your final space. So for union, you're going to just shade everything in any circle. So if you're doing union of A and B, everything in A and everything in B is valid. Like that. So the notation we use for this event is U for union, A and B. And then heads up, guys, there's a formula. Probability of A union B, it's on the formula sheet, is the probability of A and the probability of B. And then because there's some stuff that's inside both of them, you would have double counted this part. So there's a clue at the end to take away the intersection of A and B, which got double counted. So this is just, I think of this as the don't double count formula. We're not going to use that right now, but it's the first thing in the probability section on the formula sheet. So union is in either circle. So I would say the easiest way to remember that one is or. A or B, meaning you are happy with either. A happens, you're good. B happens, you're good. You're not very picky. Let's call it not picky. So in the case of the coin flips, event A and event B are a little weird. You want something that's in either circle. I tried drawing the Venn diagram this way, but it turns out everything that is in event A also happens to be inside of event B. So I went with this kind of Venn diagram where A is a subset of B. It's inside of it. So B has 7 events. 3 of them are also in A. And there's nothing else in A. And then heads up, guys, sample space on the outside. 7 of our events are in here. There's 1 out here, head, which isn't in either of those. So that's what the sample space is for on the outside, to catch everything. The idea is that the probabilities in your sample space all add up to 1. So this is a place to put that final 1. All right, so any color, right? Okay. Let me explain that as we talk about D. So what I was thinking with any color is if you happen to shade A a different color than B, for union, anything that got any color whatsoever is going to be good. Right. If you move on to the second one, intersection is about the overlap. So for this one, you're looking for things that got both colors, right? So both orange and green, which is going to be the part in the middle. So event A, the answer to D here, sorry guys, the answer to C was all of event B is the union because A is inside of B. So if you want anything in either circle, you just take circle B. For D, what's the overlap? On a normal Venn diagram, the overlap would be this middle circle, the thing that you actually subtract. This part. That's the thing we get orange and green. But this particular Venn diagram is strange or unusual. So this one, if I shaded these 2 different colors, if this was really hard to see, sorry. If this whole thing was orange and this one was green, if you're looking for the overlap, then event A is the overlap, all of it. That would get both colors in this particular case. All right, and then lastly, very important, the probability of A given B. Very important vocab. Also, this is going to be your second formula on the formula sheet, but I tend not to use the one on the formula sheet. I tend to do this from sample spaces, just being able to understand what's happening. So when you see this, guys, is the probability of A given that B definitely happens. So when you read this one, you actually have to kind of think of it backwards, right? This is the given, and this is the part you know B happened. And then think of this as an instruction to go back to your sample space and recalculate the probability of A if B happened. So you eliminate things from your sample space, some things disappear, and you get a new probability. It's like somebody's giving you new information you want to recalculate. So probability of A given that B definitely happened. In this case, if B definitely happened, all that happens in our sample space is we're going to ignore HHH, which means there's only 7 things in this new sample space that say, hey, B happened for sure, one or more tails, head is out. So now I have 7 things total in my sample space. So I'm going to divide by 7. And now we're asking, what's the chance of A happening if you know B happened? Well, there are 7 events that could be happening, and 3 of them are in A, so it's 3 out of 7.